Dear students of class 9, before starting the next exercise, let us understand the meaning of factor theorem. Let Px is a polynomial of degree more than or equal to 1 and let a is any real number such that p equal to 0, then we can say that x minus a is a factor of the given polynomial. Conversely, if x minus a is a factor of polynomial, then p equal to 0. To understand the factor theorem, let us try to solve this question. Show that x minus 3 is a factor of the polynomial x cubed minus 3x squared plus 4x minus 12. In order to prove that x minus 3 is a factor of the given polynomial of variable x, it is sufficient to show that p3 will be 0, as we know that the 0 of x minus 3 is 3. Now we put 3 at the place of x from the given polynomial, and as you can see on the screen, it becomes 0. Hence we can say that x minus 3 is a factor of the given polynomial. Now let us solve another question for better understanding of about factor theorem. Find the value of k if x plus 3 is a factor of the polynomial 3x square plus kx plus 6. Dear students, according to the factor theorem, if x plus 3 is a factor, then p minus 3 will be 0. It means if we put minus 3 at the place of x, we get 0. And as you can see on the screen, when we proceed stepwise, we get the value of k as 11. Now we can face the question bravely of exercise 2.4 of your NCERT book. Let us have the first question, that is, determine which of the following polynomials has x plus 1 a factor. As the 0 of x plus 1 is minus 1, let us find the value of polynomial at minus 1 becomes 0 or not. And when we put minus 1 at the place of x of the given polynomial, we can see that the value of the polynomial at minus 1 is not 0. So we can say that x plus 1 is not a factor of the given polynomial. Once again, we have the same situational problem in question number 3. Find the value of k if x minus 1 is a factor of the given polynomial in each of the following cases. Let us find the value of k in question number 2 of question number 3. As it is given that x minus 1 is a factor of the polynomial 2x square plus kx plus root 2. Then by factor theorem, the value of the polynomial at 1 must be 0. And as we proceed, we get the value of k as the negative of 2 plus root 2. Let us move to question number 4. As you can see on the screen, these are the quadratic polynomial, and we have to factorize this by the method that called a splitting of middle term. You have learned about it in class 8. Let us factorize the polynomial given in number 3 of question number 4. Here we have the polynomial 6x square plus 5x minus 6. In order to factorize this polynomial, we have to find two numbers p and q such that the sum of p and q should be 5 and the product of pq should be minus 36. And it is clear that the value of p must be 9 and the value of q must be minus 4. And as we proceed, you can see that the middle term 5x can be splitted as 9x minus 4x, and ultimately we are able to factorize the given polynomial as 2x plus 3 and 3x minus 2. Let us move to the last question of this exercise, that is 2.4. It is very important to learn how to factorize such type of polynomials. So we will solve number 3. Dear students, here we have to factorize the polynomial x cubed plus 13x square plus 32x plus 20. Here the constant term is 20, as you can see that on the screen, and the possible factors of 20 are plus minus 1, plus minus 2, plus minus 4 and so on. Now let us find one of the zero of the given polynomial by putting the possible factors one by one. You can see that when we put 1 at the place of x, we didn't get 0. But when we put minus 1 at the place of x of the polynomial, we get 0 as a result. By the factor theorem, if minus 1 is a zero of the polynomial, then x plus 1 must be the factor of the given polynomial. So we divide the given polynomial by x plus 1, and as you can see on the screen, the result we get is 0. That means the remainder we get is 0. Now we factorize the quotient, whatever we get, that is x square plus 12x plus 20. By the method of splitting of the middle term, we know very well. Finally, we are able to factorize the given polynomial as the factors x plus 1 into x plus 10 into x plus 12. Now, I hope that the rest of the questions will not tease you, as you can solve them easily.